So this project is about talking the effect that the climate change has in the maritime structure. Okay, so well, I am a postdoctoral research at the University of Sherbrooke. I'm from Spain and I arrived last August. So my French is not so good. I will try not to mix English and French, but well, if there are some words, sorry for me. Okay, the first thing I'm going to talk about the motivation and also talk about some problems of erosions and on maritime structure that we have around the world and in particular in the Quebecois coastal zone. Then I'm going to talk about the experimental part that I developed at the University of Granada to get some preliminary results about the debordament and some failure modes that we have in when the sea level is rising. And finally, I'm going to talk about the numerical model that we are developing at the University of Sherbrooke, and is in the beginning. So it's the first. We have the first result, and our plan is to develop a complete numerical model to simulate other scenarios and more maritime structure and different conditions that maybe we could have in the future because of the climate change. And now I'm going to finish with the conclusion and the future research that we would like to do in the future. So first, as you know, and we are talking about all the time in this presentation and this conference, the climate change have some consequence, and according to the IPCC, that is the International Governmental Panel for Climate Change, they put some effects and some previsions that we will have. For example, the temperature is going to increase, the precipitation is going to increase too, and in this part we are focusing on the sea level rise. So according to the IPCC, it's expected that in 2100 years, maybe we will have a 1 meter of rising of the sea level. So that is something that we are going to have a lot of effects as inundation around the coastal zones. That means that we will have a lot of damage in buildings around the coastal zones, and most of the population around the world, and I for sure in Quebec, lives around the coast. So we will have a lot of damage in buildings, and and also important, the damage that we will have in maritime structures. So in focusing in the coast of Quebec, according to some papers that I found, and also according to the Minister of Transport of Quebec, that says that more or less 150 kilometers of the littoral we will expose to erosion in 2100 years. So because of the effects of the climate change. I put here some figures or picture that I found it around the Quebecois coast. That, for example, you can see the erosion and the destruction of some maritime structure. Here is in the right figure. You can see the destruction of the sea walls in the Quebecois coast. So. In order to put in context, in case of you don't know what maritime structure I'm talking about, so the mainly structure that protect the coast and also the port around any place or around the world is the breakwaters. The breakwaters we call in French briselams. So it's this kind of a structure, and you will see this kind of a structure more in ports. Okay, and the sea walls, or more vertical, is that you see most in is the structure that separates the beaches and the roads that you have. So that are the two main maritime structures that we want to test in our project. So what are the failure modes or the damage that the mainly damage that you have in this kind of a structure? Well, one is the overtopping, or as you can call the debordament. So the waves pass the structure and can damage a lot of other parts of roads, buildings. Also, we have the stability of the the rocks, I mean, some of the structure, as you can see here, are composed by a slope composed by rocks or other kinds of materials. So when the waves impact with this kind of structure, some of the material can lose their bearing capacity and can fall. And the other one is the rupture or the caisson. So I mean some damage in the mur vertical. And well, this is the three main damage that we want to study, but in this presentation, I'm going to focus and present some results about the bombardment with the flow rate that we have that pass the waves, the structure, and some forces that we can have in the main caisson, and these forces can cause some damage in the mur vertical. So about the experimental test that we did. So this experimental test I did at the University of Granada. So it's in Spain, it's in the south of Spain. So we test some different models, physical models. This is the image of the wave flume that we tested, have 22 meters per long. So in this kind of test, we position some sensors. These are the sensors, the green one. So with this sensor, we measure the free surface of the waves, and we can completely perform or analyze the behavior that we have between the interaction between the waves and the structure. We tested two different physical models of breakwater, one with low burn, another one with high burn. So these are the two main models that we tested. The models have a caisson that is impermeable, but the caisson inside the caisson is empty because we want to position some sensors in order to measure the flow rate that pass the structure. Okay. We tested some different conditions. We are focusing more in waves, maybe you know because I'm talking about that. So the waves are characterized with a significant wave height and a period. So we tested some different wave period, and with each period we tested this wave meters, wave height of meters. So, but the important thing is that in order to see the effect of the sea level rise, we choose the scenario 0, that is the actual sea level, and we tested 0.4 meter. And then we, according to what the IPCC says, we increase the sea level until 0.445 meter. That corresponds to 1 meter of free surface of sea level rise, because the scale of our model was 1 meter in laboratory correspond to 22 meters in the reality. So with this increasing, we have like 1 meter of sea level rise. That is the corresponding increase of the sea level according to the scenario in 22,100 years. So the first results in the laboratory, we have more, but I present some of the main here is the, for example, the débordement sur la structure. So as you can see here, I presented the flow rate that passed the structure against to the incident wave height. So you can see that with the same wave height, we have like 2 times the flow rate if we in the worst scenario. I mean, if the sea level rise, we can have like 2 times more flow rate that pass the structure. Also, I present here the force that we have in this caisson. Okay, we position some sensors that can measure the force that we have in the structure. So here is the force horizontal and the force vertical against the incident wave height. So in general, if the sea level increase, we will have more force in front of the structure. As you can see, with the same wave height, we have more force. But it's not, as you can see, it's not a direct relation. Of the increase of the force, we have more, increase of the sea level, we have more force in front of the structure. it's not a direct relation, because we have to think that the interaction between the waves and the structure is complex and depend a lot of how the waves breaks and impact in front of the structure. So when we have different water depth, that means different sea levels, we will have different wave breaking. And according to the wave breaking, we will have different forces in front of the structure. So even if we have an increase of the sea level, we will have more forces. That is the like the tendency is not so direct as we saw in the debordament. Okay. And then I'm going to talk about the numerical model. So that is something that I'm doing with some postdoctoral mode in the University of Sherbrooke, in my department. So we are developing in the first steps, and our idea is to develop a numerical model to try to reproduce a lot of different scenarios, and also try to put different maritime structure. So with the numerical model, the things that we gain is that we can simulate more things, and also we don't have to, the laboratory tests cost more and more time. So it's necessary to have a numerical model, and also it's more easy to free like divulgation, no? So the numerical model is doing in open form. Now we are in 2D simulation, but we want to extrapolate in 3D. So the idea is to, the model is like this mesh, no? So this stem. So we generate the waves, and here is the structure, okay? So we are in the beginning, so we only test or simulate the first physical model that have the low burn, and also we also test the maximum wave height that we tested in laboratory. So it's 0.12 meters. Also, because we are in the first steps, the structure is completely impermeable. So even we have in the laboratory test, we have a burn with rocks. Here in the model, we tested impermeable, okay? Because if we test permeable, we have to calibrate some parameters that to have the flow inside the porous media, and this is something that we want to do in the future. So, well, I'm not going to focus in detail in the same different parameters that we put in the numerical model, but if you know something about numerical models, we have to define more the mesh around the structure. We use different turbulence. We use one turbulence model, try to develop in order to reproduce well the flow, turbulence flow in between the waves and the structure. And one thing that is novelty is that the air we simulate like incompressive, because if we have impact in front of the structure, the air is not compressive. That we did. Sorry. So as first result, I show you here the simulation and the debordament sur la structure. So here you can see the red that with the scenario 1, that is when the sea level increase, we have with this wave height, we have a flow rate that pass the structure. But if we are in the actual level, we don't have it. So you can see here that the numerical model reproduce what more or less have in the laboratory test, and reproduce that if the sea level rise, we will have more flow rate or overtopping in the structure. And well, as conclusion and future trial, so for the experimental research, so if we increase the sea level, we will have more overtopping in front of the structure. In general, also, if we increase the sea level, we will have more force in front of the structure, but it's not, as I said, it's not a direct relation, because we have to think about the different wave breaking in front of the structure, and we will have different consequences and different kind of force, horizontal and vertical, in front of the structure. So as a future work, we would like to test more different type of wave condition, also with different wave, sea level scenarios. And also we would like to focus, try to measure or try to capture the wave breaking depending on the different scenario that we have, because as I said and as I show, this is something important that we have to take into account. For the numerical things, well, these are the first simulation, but also the numerical part try to reproduce the experimental, and with that we want to have a numerical model that we can use in any case, and we can use with different maritime structure and different scenarios. We want to, as a future work, we want to simulate more condition, more different experimental tests. Also try to develop permeable structure, because finally most of the, not more vertical, but some breakwaters are permeable, so it's important to simulate that. Well, merci for votre attention.